Okay, on the graph paper, we're going to start with this right here. Okay, so on the graph paper, f of x equals negative x plus 2 cubed plus 3. First of all, what's the parent function? X cubed, which if I graph, looks like this. So my transformations, the negative on the outside of the parentheses is over what? The plus 2 goes 2 to the, and the 3 up 3. So the points I'm going to use, nope. So these are the points. Those are my anchor points. So I'm going to do all of the transformations to those. So I'm going to start with the 0, 0. And can I reflect 0, 0 over the axis? I can't because it's on the axis. So I'm going to move this point 2 this way and up 3. So next, I'm going to do this point. First, reflection over the x-axis. So this point is moving to right here. And then I'm going to move 2 this way, 1, 2, and up 3. So right there would be that point. Okay, you all graph the other point. Yeah. Well, that's how I've done it every single time I've graphed. It's all right here. Did you do your last point? Where is it? Where? What do you have to do first? Which I do. Then what? And? Yeah, that was hard. Okay, so there's your graph. Let's try another one. Write this one down. Okay, so what's the parent function? It is. So it looks like this. So I had one of these on the cards outside. What is the 3? It's a vertical stretch. And what is the negative? So I have a vertical stretch of 3, a reflection over the x, and then 2 up. So the points that we use for a rational or the reciprocal is -1, -1, and 1, 1. And we have 2 asymptotes. We have x equals 0 and y equals 0. And those are my 2 axes. So if I multiply the asymptotes, nothing happens. But if I move 2 up, which one of these moves? this one moves up 2. So you end up here and here with your asymptotes. So here's my first point, and there's my second point. So I'm going to do this one, and you're going to do this one. So first of all, I have a vertical stretch of 3. So this is 1, and the vertical is y. So 1 times 3 takes me to 3. And then what do I do? Reflect over the x. So this point is here now. And then what do I do? Up 2. So right there is my point. So now you do this point. So your point ends up right here. So we're going to do some composition of function today and on Thursday after the test. So I want to start with just the operation with the functions. So if there's a plus between, I'm going to add together the two functions. If there's a minus, I'm going to subtract. And see how the f is first? So the f function has to go first, and the g function goes second. If there's a multiply, we're going to multiply the two functions, and a divide. And if I'm dividing, what can it not be on the bottom? What can we not divide by? Yeah, I can divide by negative all day long, but I can't divide by 0. All right, so g of x can't equal 0. So if we look at the first example, so the first example says I want to add together the f and the g. So the f has to go first and then the g, and I'm just adding. So I'm going to have x squared plus x plus 3x minus 1. So then I'm going to combine like terms. And the last thing it says to do, bless you, state the domain. So if I start here, x squared is a parabola, and the domain of every parabola is all reals. This one is a line, and so the domain here is all reals. So do I have any number on the all reals that I can't use? No. So the domain here is going to be all reals. And I know that because it ends up being a parabola. And so I know a parabola has x squared. It has all reals. So here I'm going to subtract. The f has to come first and then the g. So I'm going to have the f, which is x squared plus x minus 3x minus 1. So why did I put the second one in parentheses? What do I have to distribute? The negative sign. So when I do that, and that ends up being also a parabola, so I know the domain of this is still all real numbers. Well, why did I do that? So on a subtraction, are you always going to have to distribute a negative? Yeah. So f times g. So I'm going to have x squared plus x times 3x minus 1. So when I multiply, I'm going to take x times 3x. And that's going to give you 3x squared, or cubed, sorry. And then x squared minus 1 is going to give you minus x squared. So then I'm going to combine like terms. And so I end up with a cubic. Do I have any restricted domain on a cubic? Nope. So my domain is going to end up all real numbers. Now for D, I'm going to divide. I'm going to have F divided by G. So the F is going to go on top. And the G is going to go on bottom. And what did I say we can't divide by? If I can't divide by 0, this cannot equal 0. So if I take, and I said 3x minus 1 cannot equal 0. If I add 1 and divide by 3, x cannot equal 1/3. So I just took this and I set it equal to 0 because we said we can't divide by 0. And so the x can't equal 1/3. Does everybody see where that came from? So that's going to be a restriction in our domain. We can't use that, right? That's a no-no. We can't use it. So the other thing I want to check real quick on top, if I factor out an x, can I cancel something? So if I take out an x, I get x plus 1. So does anything cancel? No. So I can't do anything else. So my domain is going to be x such that x does not equal 1/3. So does everybody see where I got the 1/3? We're all okay with that, right? Nobody's falling out of their desks. Okay, why could I not cancel the x's? Because there's a number in front of it, and I will punch you if you do it. Why did I not cancel the 1s? This is not just a 1 by itself, so we can't cancel that, okay? All right. Okay, so let's do the next one because we're going to do just these two because there's also a restriction on this domain. So first of all, x squared plus 9, that's a parabola, right? And what does the plus 9 do? Moves it up 9. So my parabola would look like this. So that would, if we were talking about ranges, that would affect the range, right? Because I moved that up. But it doesn't change the fact that this is all reals. This parabola is all reals. But this one, if I'm going to graph, this is the square root function, and where does that start? And it goes this way. So do I use all real numbers for this? I don't. Do I use any negative numbers? I only use x greater than or equal to 0. So let me ask you, when I add these two together, which is what I'm about to do, if I restrict this one and I said the x's can only be bigger than 0, can I use a negative number over here on this one? I can't, right? If I restrict this, it means the whole thing gets restricted. Does that make sense? So when I add the two together, I'm going to get x squared plus 9 plus the square root of x. And I'm just going to write the x's first. And so this one we do restrict the domain. This is going to be x greater than or equal to 0. And so that's not going to change when I subtract. I'm going to take x squared plus 9 minus the square root of x. And I'm going to write the x's first. So the domain is still restricted. Does that make sense? Okay, so I'm going to do example 5. So on example 5, what kind of function is the f? And what's the g? Square root. Can I use, is the domain all real numbers? If I was going to graph this, where would I start? Where? Where do I start? Negative what? For the square root function? What's the shift? Plus 6. So I'm going 6 left. So this goes here. This is the absolute value again. Which way does the minus 2 shift? 2 to the right. So this goes this way. And this is 2. So this one is x greater than or equal to negative 6. And this one is x greater than or equal to 2. If I'm going to combine those, which one do I have to use? So why the 2 and not the negative 6? So here's my 2, right? If this one doesn't start till here, can I use any of these x's? No. So you have to use this one as the restriction. So I'm just going to multiply. So when well, let's add first. So if we add them, so you can't do anything when you add them together, but you do have to restrict your domain. And if I subtract, this time the f is first. So again, you have to restrict the domain. But here's where you should pay attention because you're going to see this again. It's on the multiply one. So here, I'm going to multiply g. So my g is x minus 2 times x plus 6. So I'm multiplying. So if I was just going to multiply the square root of 3 times the square root of 2, I get the square root of 6. These two multiply together. So here's what this is going to look like. And when I multiply x times x, you end up with I just multiplied the binomials. And then what's the restriction on the domain? It's this one. Okay, one more problem. I'm going to do this last problem. So if I'm doing f plus g of 5, f plus g of 5, that means I'm adding these two together, and then I'm going to substitute in a 5. So I'm going to have 4 minus x squared plus 2x plus 8. That's the two of them added together. So the last thing I want to do is just plug the 5 in where the x is. So that's going to give me 4 minus 25